Great question on matrices here. We're first asked to find r squared by multiplying this matrix by itself. So first up, we multiply first row by the first column, a squared minus b squared. Then first row by second column, that gives 0. Then first row by third column, minus ab plus 0 minus ab. So that's going to be minus 2ab. Then second row by first column gives me 0. Second row by second column gives me 1. And then 0 again. Third row by first column, ab plus ab. Then we get 0 again. And finally, minus b squared plus a squared. I get a squared minus b squared again. So that is going to be our answer for r squared. We're now given that the constants are as shown. We're asked to determine the exact expressions for ab and a squared minus b squared to show that r squared is actually this. So ab is going to be root 2 over 4 times root 2 over 4, which will give me 2 over 16. Then I'm times in root 3 plus 1 by root 3 minus 1. That'll give me 1 over 8 when I simplify the 2 over 16, and then I'll get 3 minus 1, because I'll get a plus root 3 and a minus root 3. So I'm going to get a quarter here. Let's deal with a squared now. So that's going to be 2 over 16 when I do root 2 over 4 by itself, times it by itself. And then this time I've got root 3 plus 1 times root 3 plus 1. I'm going to end up with a third. 1 over 8, so I'll get 3 plus 1 to give me 4, plus 2 root 3, which will be 1 over 4, 2 plus root 3. And then b squared, I think it's the same, but just changing it to root 3 minus 1. Gives me 1 over 8, then it will be 4 minus 2 root 3. So therefore, r squared, oh sorry, I got one more step to do. That means a squared minus b squared is going to be a quarter 2 plus root 3 minus a quarter 2 minus root 3. The 2's will cancel actually. Then so I've got root 3 over 4 plus root 3 over 4. I'm going to get root 3 over 2. Therefore, r squared is going to be root 3 over 2, then 0, then minus 2 times a quarter, so minus a half, 0, 1, 0, then a half, 0, root 3 over 2. Okay, we've just been asked to show that it can be written like this. I can factorize a half out, which will leave me with root 3, 0, minus 1, 0, 2, 0, 1, 0, root 3. So k is equal to a half. Right, now we're asked to find r to the 6, r to the 12, and r to the 24. Obviously not just timesing them one at a time, because that would take a long time. Instead, we can use, well, r to the 6 is going to be r to the 2 cubed, or r to the 2 squared times r to the 2. So I need to times it by itself, and then again. Let me deal with r to the 4 first. So I'm going to get a quarter when I do a half times a half. Then times this matrix by itself. So we said there's a lot of matrix multiplications going on here. So I'll get 3 minus 1, I'll get 2. I get 0. I get minus root 3 minus root 3, so minus 2 root 3. 0, 4, 0, 2 root 3, 0, minus 1 plus 3 gives me 2. And I can simplify that, might as well, to a half. 1, 0, minus root 3, 0, 2, 0, root 3, 0, 1. So therefore, r to the 6 is going to be, again, a quarter, because I'm timesing this by the original matrix. Okay, so this time, root 3 minus root 3, I'm actually going to get a 0 here. Then another 0. Then minus 1 minus 3, I'm going to get minus 4. 0, 4. This is the most fiddly one, the r to the 6. 0, 4, 0, 0, which will become 0, 0, minus 1, 0, 1, 0, 1, 0, 0. Cool. Let's keep going. So now I've got r to the 12, but that's just going to be r to the 6 times itself. And suddenly, with all these root 3's gone, I think this is going to be an easier calculation. And the fractions are gone. So I've got minus 1, 0, 0, 0, 1, 0, 0, 0, minus 1. Which leaves us with r to the 24, times r to the 12 by itself. Get 1, 0, 0, then 0, 1, 0, then 0, 0, 1. Wow, we actually get back to the identity matrix after we multiplied r by itself 24 times. Finally, we're asked to describe fully the transformation represented by r. So here is r, but remember with a and b replaced by these. Okay, now after 24 applications of the matrix, we get back to the start, not after 12 or anything like that. So it can't be, say, a reflection. That wouldn't make any sense. Can't be any kind of enlargement. It's got to be a rotation. And for us to be applying it 24 times, we would have then rotated by 360 to get back to the beginning. We know it couldn't have happened any sooner. So it must be a rotation by 360 over 24, which is 15 degrees. Now we just need to think about what the rotation is around and also whether it's clockwise or anti-clockwise. And the formula book helps us out here. So rotations through theta about the coordinate axes. And it's this one here with the ry where there's a 1 in the very middle, just like we've got. So it's going to be a rotation about the y-axis. We've got sine theta here, so if theta was an acute angle, we'd get a positive here, but we've got a negative. So sine theta for us is negative. And all that means is it's going to be going in the opposite direction. So it would be a minus 15 degree anti-clockwise rotation, but we can say rotation by 15 degrees clockwise. And finally, we just need to say about the y-axis. All right, neat question here. Enjoyed that. Well done.